Hi, welcome to today's astronomy video, 5 billion Earth-sized planets in the habitable zone. This is a nice overview of some planets that are similar to Earth in size in the habitable zone of other stars. Here you can see G-type stars. They make 8% of all stars in the Milky Way galaxy. Kepler mission and the follow-up missions were a big success. Now we know that there are 5 billion Earth-sized planets in the habitable zones of G-type stars like the Sun. But G-type stars are just the third most abundant type of stars. You have 12% K stars. These are a bit smaller and a bit less luminous than the G stars. And the big majority of stars are the red dwarfs, M stars, make 75%. And these two types of stars also have Earth-sized planets in their habitable zones. This is what could be the most common Earth-type planet in the Milky Way. That's the eyeball planet. Because these types of planets could be around M dwarfs, the most common type of stars, red dwarfs. And the M dwarfs are very low luminosity. The habitable zone is very near to the star. That makes it very likely that this kind of planet is tidally locked. Means it has a permanent day side and an eternal night side. The night side could have a ice cap. And what's interesting is this transition zone here between day and night side. This could be the habitable zone of this planet. And these three systems, TOI 700, TOI is test object of interest, Kepler 62, and TRAPPIST-1, all these three systems could have several of these eyeball planet typed planets. There's another version of the eyeball world, that's the cold eyeball world. It's a world that's a bit outer in the habitable zone. And the question is, could the atmosphere freeze out on such a world? Computer models show there's enough heat transfer to the night side via the atmosphere and ocean streams that can prevent freezing. And in this context, a high heat capacity of water is important. This is a picture of how the exoplanet Wolf 1061c could look like. Orbits the red dwarf M-star Wolf 1061, which is located at 14 light-years distance. And this red dwarf has a luminosity of just less than 1% of the Sun. But the exoplanet Wolf 1061 is at a distance of just 0.08 astronomical units. 1 astronomical unit is Earth-Sun distance, 150 million kilometers. This is how it could look like in a best-case scenario. And the calculated average temperature is minus 50 degrees Celsius, but it depends on the atmosphere composition of this planet. This is a picture of how an Earth analog could look like. And one important question is how much water is on these planets. The elements hydrogen and oxygen are very common in the universe. And there are big molecular clouds in space that contain a lot of water. But still you need a delivery system. For example, for Earth, that was the giant planet Jupiter with its 5% eccentricity, collected several big asteroids towards the inner solar system. Some of them crashed into Earth and brought the water. And the second mechanism is the chemical reaction of the hydrogen from the solar wind. It's the oxides from the early dust disk, the solar system. This is a picture of how our ocean planet, our core planet, could look like. It has no mountains and very strong winds. In the solar system, there are potential worlds with subsurface oceans. For example, the moons Europa and Enceladus, and the dwarf planet Pluto. This is a picture of how a swamped planet could look like. These are hypothetical worlds with extensive areas of standing water. And this kind of planet would give creatures like reptiles and amphibians an advantage if they are warm enough. This is a picture of how a desert planet could look like. Liquid water is essential for life because of its unique properties. It is needed as a solvent and as a reactant. But even on such a planet, theoretically microbial life could be possible if there's a little water. This is a picture of a carbon planet. And these are the 5 most abundant elements in the universe. Number 1, hydrogen. Number 2, helium. Number 3, oxygen. Number 4 is carbon. Number 5 is neon. And the elements oxygen, carbon, and neon are so abundant because they are direct fusion products of the second most abundant element, helium. But the distribution of the elements in the Milky Way is not constant. For example, the CO, carbon-oxygen ratio, is higher in the inner regions of the Milky Way. That's where these carbon planets could be. They could have hydrocarbon lakes and mountains of diamonds. It's a picture of a jungle planet, like from science fiction, Dagobah in Star Wars. This planet could have similar global climate everywhere on the planet. Could have more biomass than on Earth. And we know from Earth that there's a big diversity of life in the Amazon rainforest. It's the methane planet. Methane, CH4, is a strong greenhouse gas. The early Earth had a methane atmosphere when life started 3.8 billion years ago. At that time, Earth was a pale orange dot. This strong greenhouse effect was needed because the sun has a much lower luminosity of just 70 to 80% compared to today. And in the solar system, there's a world that's the Saturn moon Titan. This potential world with a methane or hydrocarbon atmosphere and potential for life. And if there's life, it is very likely that it's very different than the life that we know from Earth. This is a picture of a phosphorus planet. Contains phosphoric acid, H3PO4. It has phosphorus compounds in the atmosphere, for example, phosphorus trioxide, P4O6. Estimated temperature is 171 degrees Celsius. So the combination of high acidity plus the runaway greenhouse effect means life is very unlikely, almost impossible on such a planet. This is Alpha planet, a Venus-type planet. Venus has a sulfuric acid in the atmosphere at average temperature 464 degrees Celsius. It has a high acidity and again a runaway greenhouse effect. There's no chance for life on Venus. And we know another sulfur world, that's Jupiter moon Io. This is the chlorine planet. It is a smoggy cold planet. It has rain of hydrochloric acid. And with this planet, there's a problem with the disproportionation of chlorine in water. It gives you HCl, that's hydrochloric acid, and HClO, that's hypochlorous acid. Hypochlorous acid is an important weapon of the immune system, but at high concentrations it's an oxidant and organic compounds can't last in this medium. This is a picture of ammonia planet. That's a cold planet. It would have lakes and oceans and clouds of ammonia, NH3. And if NH3 could replace water and could support life, then this life again would be very likely different from that from Earth. This is a picture of a super habitable planet. It has more suitable conditions for evolution of life compared to Earth. For example, it could have a denser atmosphere and a larger size. And planets around K stars. K stars are a bit less massive than the G stars, sun-like stars. Are candidates for this type of planet. This is a picture of a mega-Earth. This is a very massive Earth-type planet, even more massive than super-Earth, which are about 5 to 10 times the mass of Earth. And the question is, can life exist on such a planet? One example for a mega-Earth is K256b. It is 2.2 times as big as Earth and has 16 Earth masses. This is a picture of a mountain planet. It has strong tectonic forces. Plate tectonics and volcanism are important factors for life because they deliver minerals from the inner planet, and this supports life. It's a picture of a coreless planet. It has a giant rocky mantle without a metallic core. So this means it has no global magnetic field. So this means it will lose its atmosphere to stellar winds. For example, the planet Earth loses 90 tons of atmosphere per day, but that doesn't matter. This is a picture of the crater planet, could be a planet like Mercury. This planet has a little or no atmosphere, so this means it has a weak or no greenhouse effect. It's a disadvantage for life. However, there could be life underground. This is a dwarf planet type like Pluto. This kind of planet does not have enough mass to hold the atmosphere. This is a picture of a rogue planet, like in a science fiction Star Trek Enterprise. There's a nice model that explains the formation of the solar system. There's a variant of this model that works with a fifth giant planet. This fifth giant planet could be today planet 9 with 5 to 10 Earth masses that could be in the outer zones of the solar system, far beyond Pluto's orbit. Or it could be a rogue planet which was ejected during the formation of the solar system, was ejected out of the solar system. And potentially there could be billions of rogue planets in the Milky Way galaxy. This is a picture of Ecumenopolis, a planet-wide city. It's a concept from Isaac Asimov's Foundation series. And there's a wide age range of stars and planets from 1 billion years over 10 billion years. So this means there are not only big distances in space, but also in time. And this could be a city of a far advanced civilization. This is a nice picture of a ringed planet, a mysterious black ringed planet. It could have potential shepherd moons. The future Nancy Grace Roman Space Telescope will have a star shade, means it will be able to make pictures of the planets. And this will give us new information, for example, the rotation periods of these planets. This is a nice artist's image of how the planet Kepler 452b could look like. Could be a planet with a ring. Has about 5 times the Earth's mass. Its orbital period is 385 days. This planet orbits around the G-star Kepler 452. Which is located at a distance of 1,800 light years. It is a sun's twin because it has almost the same mass as the sun and about the same luminosity. This is a nice art. It's called In the Red of the Night by Hanno Karlhuber. This shows you the surface of an alien planet. And we know from Earth that life is resourceful and can adapt to new conditions. And this is a nice, beautiful picture. And that was today's video about Earth-sized planets in the habitable zone. Thank you for watching. Have a nice day. Bye-bye.